Hello, my name is Dylan Wilson, and I'll be presenting ongoing research about decentralized robotic foraging through local interactions. Robotic foraging uses multiple robots known as a swarm to explore an environment and return resources home. Foraging swarms are important because they're not reliant on a single agent, such as a robot, and robotic actions adapt to the environment with minimal changes to the underlying code. This is also known as emergent behavior. This is especially important for planetary resource gathering because a few robots can malfunction but the swarm can continue. Our main goal was to explore local interactions that can lead to emergent behaviors for foraging swarms. Examples in nature include pheromone trails with ants and wiggle dances with honeybees. Our group proposes a simple yet effective method, opposite velocity motion. An example scenario with an OVM controller can be seen in Figure 1. In the example, a searching robot prioritizes motion in the opposite direction of a robot going home with food. Our hypothesis is that there's a higher probability of finding food in this opposite direction. To test this out, we designed a discrete grid world simulator in MATLAB and implemented the state machine shown in Figure 2 on each robot. Next, two maps were created. One with 4 clumps of food, which was the non-uniform distribution map, and the other with food evenly spread out, and this served as the uniform food distribution map. The results of running the two controllers on these maps are shown in Figure 3. We found that the OVM robots were much faster on clumps of food than the uniform distribution map, and that random search is better for uniformly distributed food. One of the emergent behaviors to the OVM controller is that paths are formed between the home base and the food source. This likely increases the foraging efficiency for the OVM controller on the non-uniform distribution. This is still ongoing research, so the next steps are to run a large number of simulations to explore how tuning the specific robot parameters changes the foraging efficiency of the swarm. Some parameters we would like to change and adjust with simulation are the scan size, the wiggle motion, the conformity duration, the number of robots, and the different food distributions within the simulation. Our team would like to thank Dr. Yu Gu for advising us and the NSF for funding this research. Thank you and have a nice day.